Alright, this video is going to go through the definitions of the process of combinatorics, which is going to be the beginning part of looking at some probability. This is something that we're going to cover kind of in most math classes a little bit. Alright, so combinatorics, by definition, it's kind of just creating how many different combinations or possible outcomes out of a set of values. So when we look at combinatorics, there are two different ways that we could look at the different outcomes. And we're going to classify those as a permutation or as a combination. So permutation or a combination. And this whole process is kind of, if you think of combinatorics as counting, right? You're counting how many different ways can something happen. Okay? How many different ways could your desired outcome happen or come about. So when we take counting or combinatorics and we break it into these two different categories of permutation and combination, you just got to know which one you're dealing with in the given situation. So a permutation, if you think of permutation starting with a P and you think of positioning, this is when the order matters. So when you have something, you're trying to figure out the outcomes, but the order matters. So whatever is selected first has a different level of outcome than what is selected second or third. This would be something like a race, where if you get first place versus second place versus third place, it could be winning different rewards, for a lottery or a raffle where one person wins the grand prize and then the second one wins a lesser prize, third person, so on and so forth. So anytime that the order is important, it is a permutation. Okay? So again, what I was saying was things like a race, different winners, different winning rewards, something like in sports, a batting order, right, or any kind of a lineup. Even if it's a band lineup, whoever performs first or second or third, it kind of creates a different total amount to that level. Right? So you're either the opening act or you're the star performance. The order, it matters. Okay. The combination is when the order doesn't matter. Right? So there's no specific order that's important. It's kind of more of just being selected. So in this case, just some examples here, it would be, maybe if we look at the racing, maybe a track race in the Olympics. Right? Obviously, winning gold, silver, and bronze, each one of those has a different level. And then even if you finished fourth, you don't win any medal. All right, so first, second, third is kind of important because you want to win the gold medal. All right. The combination side of things would be, if you've ever followed a track and field event, you have qualifying heats. So if you finish in maybe the top 3 in the qualifying heat, you move on to the next round. Right? Then if you finish in the top 3, you move into the next round. And then when you get to the finals, then it becomes a permutation. All right? So there's if as long as you're being selected in a combination, That's what's important. All right, so there's not a specific set value or a set order that makes one place value or position more important, like the permutation. So some examples of a combination. All right, I just kind of said the qualifying race, where you move on to the next round. Some other ones would be if you're just choosing a committee. So from a school standpoint, so if you're choosing something like student council, as long as you make student council, you're on student council. All right, there's nothing that it says if you got picked first for student council, then you are in a different level. It's not like saying if you're picked first, you're the president. If you're picked second, you're the vice president. Well, that becomes a permutation. All right, the combination would just be, hey, you got picked. If you're choosing, if you have 10 books and you're going to read 3 of them, it doesn't matter if you pick the book first, second, or third. It's going to get read. All right, you're going to watch movies. You have 10 movies and you're going to watch them all. It doesn't matter as long as you're just watching them. It gets picked. That's what's important. That's a combination. Now, if you're going to look at the Harry Potter series and you have the whole set of movies, it matters which one you watch first, second, or third. That becomes a permutation. Right? So if you're going to watch the first Harry Potter movie first, that becomes a permutation because you're assigning a value. All right? But if you just have 3 random movies that you're watching, as long as it doesn't matter the order, you just watch one and then that one's over, you watch the next one, that's a combination. All right? So if you assign a value, first, second, third, fourth, fifth, so on and so forth, that's permutation. If you're just selecting it out of a group, that's a combination. Kind of looking at that second one here with the winning of a reward, if there's equal prize value, if everybody that gets picked, so if your name is put into a hat for our whole class, and I said I'm going to pull a name out and you win extra credit. If I'm going to pick 3 students from our class, it doesn't matter if I pick you first, second, or third, you're all getting equal extra credit. That becomes a combination of possible ways that you could be selected. Now, if I said the first person gets 3 points, the second person gets 2, and the third name I pull gets 1 extra credit point, that's a permutation because I've assigned a value. So if you assign a value or it's important with the order, it's a permutation. If that's not important, you're not assigning a value, you're just choosing it, that becomes a combination. So now, to calculate some of these things, a lot of them are going to come from a symbol that is called a factorial, which is the exclamation point after a number. What that means is you're going to start at that given value. So in my example here, I'm going to start at 4. And what I'm going to do is I'm going to multiply all the way back to 1. So I'm going to say 4 times 3 times 2 times 1. So you're dealing with only integer numbers. So when I do that, I get 24. So factorial is going to be used while we're doing counting, while we're doing permutations, while we're doing combinations. These are always positive numbers. They're not going to be negative. So if we started at 6 factorial, 6 factorial, we would start at 6 times 5 times 4 times 3 times 2 times 1. So that becomes 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2 is 720, times 1 is 720. Okay, so factorial is just a way of creating this repeated pattern of multiplying. And when factorial is going to be used a lot is just understanding the number of counting the number of possibilities. Okay, so that'll be the next thing that we kind of look at. But if we're counting the number of phone numbers that are a 330 phone number, that becomes something that we'll use a factorial if we're not repeating a number, say. Okay, so if after we have our set values, how many numbers do we choose from? Well, if we have 10 numbers to choose from and we pick one, well, now we have 9, and then we have 8, and then we have 7, and then we have 6. So that's where the factorial comes from. It just means that you're not repeating anything. Okay, so as we look into counting the number of ways something can happen. All right, so if we're counting the number of ways that something can happen, if there are no repeats, all right, so if we're not repeating a letter, so let's say we're going to do a license plate. Okay, so and this is where you kind of have two different categories within this counting process. So one is if something repeats, and if it does not have any repetition. Okay, so again, if we look at a license plate, all right, so if we know we have a license plate and there's going to be 5 numbers on that license plate, all right, and we're going to only deal with, we're going to say within this license plate it's going to have a letter, and then the rest are going to be numbers. So, if our license plate has 2 letters followed by 3 numbers, if you're allowed to repeat, what we're going to have is we have 26 letters of the alphabet, so there would be 26 and 26, and then we have 10 numbers. 0 through 9 is 10 numbers. So this means that that license plate could be AA111. It could be AA222. It could be AA122. It could be AA121. Right? So again, you're just kind of multiplying out the number of possibilities. Now, if there's no repeating, this is where factorial kind of comes in. So within the letters, it's kind of like saying we're going to do a little bit with the n factorial of 26 times 25, but then we're going to stop because we're not going to have 26 values on this license plate. So we would have 26 letters, but now if we pick the letter A, we can't pick that anymore. So we use 25. When we choose our first number, let's say we picked a number 1. Well, now when we pick our second number, we only have 9 numbers to pick from because you can't repeat. And then you have 8 numbers to choose from. Okay, so within this counting the possibilities, what we're doing is we're choosing what is happening based on how many possible ways could that happen. How many ways could we pick a letter? How many ways could we pick a number? All right, so again, you're paying attention to, does it repeat? Does it not repeat? Okay, when we're counting the possibilities. A very common question like this is dealing with a menu at a restaurant or putting on an outfit. All right, so, and what you're going to do with counting, you're just multiplying all of your possibilities together. Okay, so, this whole thing is multiply. Possible ways together. Right. So if we, had, as far as a main entree at a restaurant, let's say the restaurant had 10 to choose from. If you had a side dish, and maybe they have 8 sides for you to choose from, and let's say you have the number of different drinks that they offer on their menu is, say, 5. And then if you want a dessert, let's say they have 4 desserts. So if you were picking, just to try to figure out how many different ways could you choose your menu, if you were getting a main, a side, a drink, and a dessert, what you would do is multiply 10, 8, 5, and 4. Multiply all those together. And that'll tell you how many ways that you could pick your menu item. Let's say you pick 2 side dishes. So now you'd have a main item, a side, a drink, and a dessert. Well, in this case, you would have 10 main courses to choose from. You would have 8 side dishes. Now, if you're not allowed to pick the same side dish, let's say that we would have 7. Now, if the restaurant allowed you to pick mashed potatoes and mashed potatoes as your 2 sides, well, then you would have 8 and 8. You would still have 5 drinks to choose from, and you would still have 4 desserts to choose from. So you would, again, multiply all that together. All right, so when you're counting, you're not really putting anything in order. We're not looking at, the breakdown of, is there a place value assigned or not, like we do with the combinations or permutations. With counting, we're just trying to figure out how many possible ways can this happen. Okay. A phone number, like I think I said right at the beginning. Right? A phone number has the 3 numbers of the area code, and then you have your 3 numbers of your local code, and then you have your 4 digits at the end that assigns your phone number to you. So if you know that your phone number is going to be 330, you take those 3 away, and now we're focusing on what are the last 7 numbers that you could possibly have. And it would be a 10 and 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 a 10. Right, so if you just wanted to know how many phone numbers are possible in the United States, you have, like I said, 10 numbers. 3 numbers for your area code, 3 numbers for your local code, and then 4 numbers for your phone number. And it's your extension number. So when you have that, you would have 10 to the 10th power, 10 times 10 times 10, 10 times. And that would create how many phone numbers in the United States could happen. Right? I know there's restrictions because I don't know that anybody has a phone number of 10 zeros or 9 zeros and a 1. Okay, I don't think that's a possible phone number, but hypothetically speaking, that's how many phone numbers could be created. Okay? And the same is true with a social security number that you have. Okay? When you apply for a credit card someday, or you go to college and you have your social security number, that assigns you to all of your financial and credit information and all that kind of stuff. There's 9 numbers in that social security number. Okay? So that number is specific to you. And again, you would have 10 numbers in all 9 of those spaces, kind of like we did here with the license plate. All right, so that's counting just the number of possibilities. Okay, so now we're going to break down the difference between permutation and a combination. Okay, so a permutation, when order is important, right, the formula is a little bit complex of a formula. We're going to say this is N, and then P stands for permutation, and then R. And N is the total amount of them possible, and then the R represents how many you're choosing. So if you have 10 people running a race, all right, so we have 10 runners, and we have 3 win gold, silver, and bronze. It becomes a permutation problem. All right, so the formula, we're going to take this N, and that's going to go in the numerator of the fraction, but it's N factorial. And on the bottom, you're going to figure out what n minus r factorial would be. So you take how many people are running total, and then on the bottom you're subtracting kind of your three winners. So the bottom is created by the non-winners factorial in this example. All right, so what we would do is this would be 10 factorial over 10 minus 3, which is 7 factorial. So here's what happens in the end on the whole formula. This is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And it's divided by 7, 6, 5, 4, 3, 2, 1. So now, just looking at simplifying, 7 and 7, 6 and 6, 5 and 5, 4 and 4, 3 and 3, 2 and 2, 1 and 1. So in the end, there would be 720 ways that these runners can finish first, second, third, gold, silver, bronze. Okay? So you don't have to list all of them. On a calculator, a lot of times this formula right here is on a calculator. Depending on your calculator, it might be listed underneath a stat button. I'm not sure on a phone, unless you download a specific scientific calculator. That's probably not one of them on your default Android or Apple calculator. But if you get a scientific calculator, if you have a Texas Instruments calculator, there's probably a button that says stat. Sometimes it says math. My graphing calculator that I have, you have to go underneath the math window, and either right there as an option is NPR, or sometimes you have to even go into another little breakdown tab of probability, PRB, and then you can choose this. But you would put in the number 10, press the NPR button, put in the number 7, hit enter. It's going to do it for you. But notice when you have this number here of 10 and we have this number of 7, really all we have to do is multiply the factorial of 10 until we get to 7. So we just went 10, 9, 8, but then after 7, that crosses out. And then that's how I got 720. Okay, so that's how you use a permutation formula. If you're dealing with a bigger group, or you're dealing with more winners, or what have you. If we have 15 players on a baseball roster and you're trying to create a batting order of 9, it would be 15 factorial over 15 minus 9 factorial, which would be 6. So now we would have to multiply from the 15 and times 14 times 13 times 12, 11, 10, 9, 8, 7, and then from 6 on is going to cross out. So we would actually have to multiply from 15 to 7 in that example, just because of what would be remaining. Right? Again, it's your total number, and then really the denominator, since it's really the total minus what you're picking, it's whom are you not picking. So in the batting order example, like I said, if we had 15 players over the 15 minus 9, because 9 people are in the lineup, well, these would be, the bottom denominator here would be those that are not in the lineup. So it really becomes 15 factorial over 6 factorial. So we have to multiply 15 times 14 all the way until we get to the 7, and then that would be the total number of ways that we could randomly choose that batting lineup. All right, so that's a permutation. Okay, a little bit of an advanced formula. Just got to, number one, identify that you are using a permutation because the order is important, and then after that, I either identify how to do this in the shortcut method using this NPR button on a calculator, or write out your fraction, and then, like I said, you would be 15, 14, 13, 12, 11, 10, 9, 8, 7, and then 6. So from the 6, that's going to cross out with this bottom. So your final answer would be multiplying all those together. So it becomes a little tedious because you got to multiply a lot of numbers together. Right. The last part, a combination. All right. So the one thing I always use as an example, and you may have heard this before when you deal with this, we call them combination locks on our lockers at school. And we say our locker combination, and everybody forgets their combination. It's actually not a combination, because remember, back to the beginning of this little video, a combination, there's no order that's important. With our lockers at school, you have 3 numbers. It matters which you put in. So if your locker combination is 1, 2, 3, you have to put number 1 in first, then you have to put in number 2, then you have to put in number 3. And you got to spin the dial to the right, and then to the left, and then to the right again, and then your locker hopefully opens. Okay. That's not a combination. That's a permutation, because the order was important. Okay. So if a combination, if it really is a combination, and I have the passcode 1, 2, 3, that means 3, 2, 1 would work. That means 2, 3, 1 would work, because that's all the same combination. All right, so it's not a locker combination. It's really a locker permutation. All right, so combination, remember, the order is not important. So don't think about the combination lock on your locker. All right, so the combination formula, instead of NPR, this one is NCR. It's kind of the same. We have N factorial. We still have N minus R factorial, but then you also have R factorial again. Because what that does is it actually, it will divide out in the bottom the overlapping ones. So again, that locker combination of 1, 2, 3 could go 3, 2, 1. It could go 2, 1, 3. It could go 2, 3, 1. It could go 1, 3, 2. All of those involve those same values. All right, so we only count that one time out of the total. So that's why you divide all the repeating ones that you're choosing. All right, so let's go to an example of, let's say we have 15 students that are running for student council. So we have 15 students total. All right, we're going to choose 4 student council members. All right, so this is N, and this would be R. So our formula that we're going to go to is 15, and then we are choosing as a combination 4 of those students. So we go into our formula. Okay, again, we have 15 factorial. This time we have 15 minus 4 factorial, and then 4 factorial. Okay, so again, if you do this the long way, again, you're going to be able to find that formula on your calculator if you have the other one underneath the stat window. But if not, it becomes, you got to multiply all this out. So you have 15, you have 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just fit. And on the bottom, 15 minus 4, that's 11. So we start at 11, 12, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But then we also have another 4 factorial. So we have a 4, a 3, a 2, and a 1. So now we can go through and cross out. So notice, 11 all the way down to 1 crosses out with all of these. So in the simplified format, once you know that we have a 15 factorial and we're subtracting the 4, which makes that 11, we can just multiply from the 15 all the way until we get to the 11. So 15, 14, 13, 12, but now we get to the 11. So then you just have to divide by the 4, 3, 2, 1. So notice how many possibilities get eliminated because these are the repeated pattern. All right, so this is like person A, B, C, and D, out of our A through O, if we listed out, person A, B, C, D, E, F, G, so on and so forth, and we had our 15 people, and we're only choosing 4 of them. Well, if we pick those 4, A, B, C, D, could be the order that it was picked in. It could go B, A, C, D. Well, that's the same 4 students that got chosen to be on student council. So that's why we have this extra, because it's going to eliminate. So when you look at it, combinations are always smaller than permutations. Right? A permutation is always going to give you more possible outcomes. Right? So that's why a locker permutation is what it should be called. It gives you many more lockers that we can assign that have different values, numbers to put in to open up that locker. All right. Same thing on a passcode or on a debit card. You have a 4-digit PIN on your debit card. Well, a permutation is what that is, because it matters the order that you put in your numbers. Okay. Whereas if it was a combination, it eliminates a lot of the ones that you could put in. Right. So it's much more secure and safe to have it as a permutation, where the order matters of what values you put in, versus the combination. Okay. So hopefully this gives you a little bit of a better explanation and understanding of how these formulas are. Use the notes that I'm going to send to you, and utilize that as you move forward doing any of these practice problems. But first and foremost, you got to know the difference between just counting permutations, and counting combinations. Okay. Then it goes to the formula and which value you plug in where. And like I said, if you can find these formulas on your calculator, it is going to save you a whole lot of long fraction multiplying things out. All right, but like I said, first thing first, be able to determine which type of combinatrix you are using, whether it is a combination or a permutation.